Hello, my name is Morenike Adibodun. This is project 2. We are 2 in this group, and the second person is Thomas Metu. This is based on project 2, based on the paper that we read titled Clustering Through Decision Construction. The authors of this paper are Bing Liu, Yang Xie, and Philip S. Yu. This is the outline of this PowerPoint slide. We're going to look at the motivational factor, why the authors of this paper did what they did, their main objectives. Then from there we go into the introduction and how to build a cluster tree and the results of the experiment. Then we'll talk a little bit on what they did and the conclusion, then their personal opinion on this paper. First of all, their motivational factor is based on decision tree algorithm that uses a priority function to partition the data space into different class regions, but the technique not directly applicable to clustering. Is they wanted to develop some new algorithm, and this was what motivated them into this project. The main objective or purpose is a novel clustering technique which is based on a supervised learning method called decision tree construction, and the short of it is CL3, that is clustering based on decision tree. The introduction is that we're going to see what a decision tree is, that is the data. How do you build a tree based on the kind of data collection or the data you want to the data mining you're trying to do or extract. So this decision tree uses a priority function to partition the data space into different class regions, and these class regions could be, for example, students in a school, the professors, whether they can use their qualifications and things like that. So all these data will be based on class region, and the technique is not directly applicable to clustering. The introduction is that if there are clusters in the data points cannot be uniformly distributed in the entire space. Now, if you look at diagram A, those black dots you're looking at, they are data that are collected. That is, they have common attributes. So, in order to be able to extract the ones that are useful, then there must be a kind of method on how to partition the data and extract the ones that are useful and the ones that are not useful. If you look at the diagram B, you can see some rectangular shapes. That's the partition done, and the little circle dots you're looking at are data that are not actually needed. So you do this based on the decision tree, and finally you sift out the data that are not needed. You can see at the end of it in the third diagram, which is the C diagram. But the issue is that if there are clusters in the data points cannot be uniformly distributed in the entire space. So it's going to collect some more, some little, and things like that. So the CL3 technique consists of 2 steps. The first step that is to be done is that cluster tree construction has to be formed, and this you will use a modified decision tree algorithm with a new priority function, and also cluster tree pruning. That this one will help you to find meaningful, useful clusters. Because if you don't do the pruning, there will be some data that are not actually useful to what you want it to be. Like if you're collecting information about professors in the school, depending on, probably you want to use their qualifications, probably an associate lecturer and full PhD lecturer. So if you don't prune it, you might end up not collecting a useful clusters. Now we want to see how we build a cluster tree. This is the picture of a cluster tree that is being used. We can see the data points, the X, Y, and X. See the tree, how it is built. So based on that, we connect points together, the X and Y axis, and then partition using the rectangular form of shapes. This is an example of a decision tree. And we do not physically add the endpoints to the original data, but only assume their existence. So we now determine how many endpoints that we need to add. So this is another example, how you distribute the endpoints. So introducing the endpoints, which is usually introduced at the beginning, the reason is that we need to increase the number of this point of a node if it has more inherited Y points than endpoints. The Y points are the points that are not that useful to the clustering. So to avoid the situation where there may be too few endpoints, it's usually left, we leave after some cuts or splits has been done. So the effect of using a fixed number of endpoints is the figure that you are looking at. Now there are two modifications to the decision tree algorithm. The first one is that you need to compute the number of endpoints on the fly and then evaluate on both sides of the data point. Now this is an example of the space that has 25 type of data, which is the Y point, and the end point is the exact data that you needed. And if you look at this other figure, it's talking about clustering, cutting on either side the data point for you to be able to collect like data. This is what this algorithm does. And we have new criteria. There are two main problems with the gain criterion. The cut with the best information gain tends to cut into clusters. This results in severe loss of data point in clusters. In this next slide, we saw all the various points that was cut, the initial cut and the cut that is ahead, that to find a better cut. Then we select the overall best cut, and this is the figure determining the best cut. This is the program for the algorithm. This program is the one determining the best cut of the CL tree, and it is user-oriented pruning of the clustering tree based on browsing, which is the user simply explores the tree himself to find meaningful cluster, and the user-oriented pruning also is the tree is pruned using two user-specified parameter. You have to specify the parameter you want to use. This is the program that tells you the cluster tree pruning. This is the algorithm. And then after doing all that, you now do the merging of the adjacent region and the simplification of the clustering, which defines the AY region and is set to touch another Y region. So look at this, is the program fragmenting of the clusters, that will help fragment, that is partition the useful data and the ones that we don't really need. And this is the result of the experiment. That is the scalability with the dimensionality of hidden clusters and the scalability with the data size. This is the result of the experiment that was done. And the experiment continues. We saw the percentage of cluster data found with the minimum Y, and the percentage of cluster data point found with the minimum RD. The conclusion and the personal opinion of the author is that he proposed a novel clustering technique called CL3, which is based on decision tree in classification research, and the result shows that it is both effective and efficient. In what we did, we tried to add some other programs to this, so it is self-explanatory. We included this program in implementing the clustering algorithm and its working details. So it's well detailed in the programming that we did. Thank you as you look into this presentation. And we appreciate Dr. Pan for his time teaching us throughout this semester on data mining. Thank you. Bye.